In this episode, I'm going to give you a brief introduction to the Flutter application framework, and we're going to start off by creating a new blank Flutter project in IntelliJ. That's the IDE that I'm going to be using. You can also, at the time of recording, use both Android Studio and Visual Studio Code, amongst others, if those are more to your liking. So I've already gone on ahead and installed Flutter onto my computer. I'm running Ubuntu version 20.04, and I have the latest version of Flutter from the master channel. So I've opened up IntelliJ here, and I'm going to create a new Flutter project. You can see there I've got my Flutter SDK path set up in IntelliJ. And I'm just going to give this project a name of just app because I'm ultra creative. Keep the use Android X artifacts ticked, and then the Android language set to Kotlin and iOS set to Swift. Project type, application. So once you're happy with those settings, feel free to tweak them to your particular need. Click on the Finish button down here, and this will generate me a new Flutter project. It will take just a few seconds to create the project and open it up in IntelliJ. And here we have our basic Flutter application. You'll notice here it pops up saying just to configure the Android framework that it detects. You can simply click on Configure and hit OK. Just leave that running away in the background. And this is the README for our application. You can see there just a new Flutter project. That's the description that we used on the Create Project screen. And just a little bit about getting started. If you're new to Flutter, then I would highly recommend checking out the interactive lab on the Flutter site, which takes you through creating your first Flutter app in more detail. And likewise, the cookbook contains a number of useful Flutter samples if you're interested. So now we've got our application open here in IntelliJ. I'll expand the project folder, and you'll see here that we have a folder for Android, we have a folder for iOS, a folder for Linux, a folder for macOS, and a folder for Windows. These are each of the specific build environments that Flutter can build for. So at the time of recording, Flutter supports both Android and iOS. It also supports web, and it also supports Linux, macOS, and Windows Desktop. So if you're on a Windows machine, you can compile your application into a .exe, and likewise you can do similar with Linux and macOS if you're on those particular desktop operating systems. You'll notice then we have a standard gitignore file if you're using a Git repository to store your source code. We've then got some metadata and packages. You can just ignore these. These are auto-generated by Flutter. We've then got the IML file, which is used by IntelliJ to structure the project in this sort of project window we've got open here at the side. You can ignore that if you're using an IDE such as Visual Studio Code. We've then got the pubspec.yaml and the pubspec.lock file. If you're coming from a web development background, the pubspec.lock is synonymous with the package.lock.json in NPM. This essentially lists all of the packages and the versions that we have of said packages. And the pubspec.yaml file is synonymous with the package.json file. You can see there the name that we used of the project when we created the project in IntelliJ, the description, which we just left as the default, a new Flutter project. We then have publish to none, which means that pub publish won't work, meaning that we can accidentally push our application up to the pub registry. Pub being the place where you can get packages, much like NPM and also NuGet. Dart uses the pub package registry, which is where you can browse a number of different community-based packages for your Flutter project. You'll notice then the version field is 1.0.0 plus 1. As you can see from this comment here, the version number is 3 numbers separated by dots, which is this 1.0.0, and that's followed by an optional build number, which is separated by a plus. So you can see you can override these manually when you do a Flutter build by specifying the build name and the build number parameters. When you're building for Android, the build name, which is this 1.0.0, is used as the version name, whereas the build number, which is this 1, which is optional, is used as the version code. If you don't specify the version code here, then you can either pass it in using the build number parameter of the Flutter build command, or you can specify it in your Gradle configuration. Similarly, on iOS, the build name, this 1.0.0, is used as the CF bundle short version string in the iOS configuration. Meanwhile, the build number, which is this optional 1, is used as the CF bundle version in the iOS configuration. Likewise, you've then got these two links here, linking to the Android documentation for versioning, and also to the iOS documentation for versioning. You can see here that we specify our Dart SDK environment. So we're specifying that this Flutter project is compatible with version greater than or equal to 2.7.0, but less than 3.0.0 of the Dart SDK. Moving on, we have our Dependencies section. This again is synonymous with the dependencies that you'd find in a package.json file if you're coming from a web development background. We specify the Flutter SDK dependency because, as I'm sure you can imagine, we're going to need the Flutter SDK to create our Flutter app. We've also got a reference to the Cupertino icons package. This pulls in the Cupertino icons into our bundled application. We're specifying here greater than 0.1.3. You can read more about semantic versioning in the pub documentation. Moving on, we have our dev dependencies, which are again synonymous with the dev dependencies in a package.json file. And we specify that the Flutter test package comes from the Flutter SDK that you will have downloaded and installed before this guide. Finally, specifically for Flutter projects, we have a Flutter section in the pubspec.yaml file. This specifies that we are using material design. This means that the material icons font is included with the application, amongst other things. If you aren't using material icons and you aren't using any of the material designing, then you can set this to false or remove it completely. Next up, you can see here how to add image assets to your application. You can see here that this images folder would exist in the root of the project alongside all of these other folders. And then you've also got a configuration for custom fonts. By default, the application will use the Roboto Android font. However, you can, if you choose to do so, include your own custom fonts into the built application. You can specify the font family, so the name for the font, and then you can specify a list of font assets, specifying the style, whether they're normal, bold, or italic, and also then the weight for adjusting the boldness of the font. You'll see there, much like the images folder, the fonts folder is also stored in the root of the project, so you would create a fonts folder alongside all of these other folders. And that's the general convention for laying out images and fonts in your Flutter application. So that covers the basics of the pubspec.yaml. And finally, you'll notice earlier on that we missed out this lib folder. This is where the main application source code lives. You'll notice that we have a file called main.dart. As I'm sure you're familiar with, Flutter uses the Dart programming language, and you can read up more about Dart on their website. You'll see, much like a traditional application, you have this main method. This is synonymous with a main method in the likes of Node.js and .NET. This main method calls the runapp method, which is provided by the Flutter framework, and we specify that we want to run my app. You'll notice that we have a MyApp class, which extends a stateless widget, and this is essentially the root of the application. This build method returns a material app, and it has a title of just Flutter Demo, and it also specifies a custom theme with a primary swatch of blue. Likewise, there are a number of other colours to choose from, for example yellow, white, green, blue, and more. You can also provide your own custom colour palettes to suit your branding requirements. We'll leave that as blue for now for the purposes of the demonstration. Finally, you'll notice this visual density property. We set the visual density to be adaptive platform density, which means that the visual density will adapt to the specific platform that the application is running on. As we mentioned earlier on, at the time of recording, Flutter applications support a wide variety of platforms, such as mobile devices, web browsers, and desktops. This means that controls may be smaller and closer together, more dense, on desktop platforms than on mobile platforms, and specifying this adaptive platform density means that Flutter will automatically adapt the density of its widgets based on the current platform. You can override this if you choose to do so and have a custom visual density based on your own particular requirements. Finally, you'll notice that we have this home property, and this specifies the default root of the app. That's the root that's displayed first when the application is started normally. As you can see, we have the home set to this My Homepage class, which is just down here, and we're passing in a title of Flutter Demo Homepage. You'll notice here that title is an optional parameter. This is the general convention that you'll find across the catalogue of Flutter widgets, with properties generally being marked as optional. The My Homepage is a stateful widget this time, which means that it contains its own state. You'll notice that My Homepage has this override method called createState, and this creates the page's state. You'll see here that My Homepage state corresponds with this state class just beneath. General convention is, if you have a stateful page, then that particular page will have its own private state class. For example here, My Homepage has a state called My Homepage state, and the underscore means that the class is private, so it's only accessible by other classes in the same file. This is slightly different to the My App, which is a stateless widget. Stateless widgets just have a single build method, whereas the stateful widgets have a method called createState, and the state class itself houses the build method. You'll notice here in this class we initialized a counter variable and set it to 0. We have an increment counter method, which inside this setState function increments the counter by 1. If we didn't have this setState callback function, then whilst the counter value would be incremented by 1, the UI wouldn't be updated. So if you're making changes that require the UI to be re-rendered, then you need to do so inside a setState method. As this, as you can see by the comment, tells the Flutter framework that something has changed in this state, which causes it to rerun the build method below so that the display can reflect the updated values. As you can see there, if you changed counter without calling setState, then the build method would not be called again, and so nothing would change in the UI, even though the backing value will have changed. So it's important, whenever you want to change the UI, that you call this setState method, and that will then recall this build method, which rebuilds your UI. This build method is responsible, as we just discussed, for creating the user interface, and it's rerun every time that the setState method is called. You can see this build method returns a scaffold, which, if you like, is the bare bones widget that forms an application. The scaffold, an application page I should say, the scaffold has an app bar, a body, and a floating action button. The app bar appears at the top of the page, and we specify the title to be the widget's title, which we passed in as Flutter Demo Homepage. You can see that refers to the title here, and widget.title again refers to the title that was passed in. So to refer to any properties in your home page class from your state class, you simply say widget dot and then whatever the property name is. In this case, as you can see, the property name is called title. Moving on to the body, we have a center widget. Now this is a layout widget which takes a single child and positions it into the middle of the parent. So this means that the column is going to be center aligned in the body of the scaffold. The scaffold, as we mentioned earlier, being the bare bones widget for the page's structure. The column takes a list of child widgets to display in a vertical layout. If we had a row widget, then that would be represented horizontally. You'll notice here we have a concept of main axis alignment. Because the column widget is vertical, the main axis alignment runs vertically from top to bottom. This means that the children widgets will be center aligned vertically on the page. There's also another property, as we can see, called cross-axis alignment. In a column, because it's vertical, the cross-axis alignment runs against that layout, meaning that in this case the cross-axis alignment represents how the children are aligned horizontally. Likewise, if this child was a row, then as previously discussed, the main axis alignment would run horizontally and the cross-axis alignment would run vertically. By default, the cross-axis alignment is set to be center aligned. So with this main axis alignment being centered, it means that these children will be centered vertically inside this column widget. And we have two text widget children inside the column. The first being this text widget saying you have pushed the button this many times, and the second text widget being the value of the counter. You can see here we specify a custom style for that particular piece of text. Theme.ofContext essentially gets the theme of the context for this build method, specifies text theme and headline 4. There are a number of different headlines, 1 through to 6, and these are synonymous with the H1 through H6 tags if you're coming from a web development HTML background. You will also notice that aside from text theme, there are a number of other themes available, such as button bar theme, button theme, card theme, and many other themes matching those particular widgets. We'll leave that as just a headline 4 text theme, meaning that the value of count will be displayed on the page as if it was inside the H4 tag. Finally, at the bottom of this build method, we have a floating action button. You can see that we have the onPressed callback being this increment counter function. That was defined further up, and that's what increments the counter by 1 inside the setState callback. SetState meaning, of course, that the UI re-renders by rerunning the build method. The tooltip is set to increment, so that on a desktop, when you hover over the floating action button, you'll see a tooltip with the text value of increment. Likewise, if you're on a mobile device, you can activate the tooltip by long pressing on the button. Finally, the child for the floating action button is this add icon. You'll notice here that the trailing commas make auto-formatting nicer for build methods. Flutter, as you can probably tell, is a fairly nested application framework, and that means it's quite often the case to split your widgets out into child widgets, and it also helps with styling if you use trailing commas, and you can use the automated formatting tool called Dart Format, which under the code menu, reformat code with Dart Format, and that will automatically reformat the file. And providing these trailing commas helps Dart Format to format the file in a way that makes it as easy to read as possible. So this covers the main.dart, which contains the MyApp class and also the MyHomepage class. This has been a bit of an introduction to the Flutter application framework. I hope you found it useful, and thank you very much for watching.